So now we are going to solve a second problem related to shear force diagram and bending moment diagram. Example number 2. And this example is related to a cantilever beam. So we have a cantilever beam subjected to a single point load, magnitude 10 kilonewton, and we will label this point as point A, and this point is point B. Span of the beam is 10 meters. So let's see how can we draw it: shear force diagram, bending moment diagram, and elastic curve. As we know that the first step of solving this problem is to calculate the reactions. So first of all, let's identify that what reactions will be there. We have a fixed support at this end, so we will have a vertical reaction here. Let's call this reaction as VA, vertical reaction at point A. Will there be a horizontal reaction at point A? I think no, there will be no horizontal reaction at point A because there is no horizontal force acting on the beam. So no action, no reaction. And then movement. This force will produce movement about point A in clockwise direction. So I expect that there will be a counterclockwise movement. Let's call this MA, the reactive movement at support A. And again, even if the assumed directions are incorrect, that does not matter. I will get a negative answer, and in my calculations further, I will change the direction of these reactions if I get negative answer. Okay, so now let's apply the conditions of equilibrium and calculate the values of these reactions. So we'll apply sigma Fy equal to 0, and our convention is upward positive. So how many forces are acting in y direction? We have one force VA that is acting in upward direction, so positive VA, and other force is the applied load of 10 kilonewton, which is acting in downward direction, so minus 10, and this is equal to 0. So this implies VA is, so this gives us the value of reaction at point A is equal to 10 kilonewton, and we have got a positive answer. It means the assumed direction of reaction is correct. Next, we will apply sigma MA equal to 0. Sigma MA equal to 0. Now, for sigma MA equal to 0, what are the moments present in the system? Let's say we start from the same end. MA is in counterclockwise direction, so according to our convention, it should be minus MA. Let me write down the convention here. Our convention is clockwise positive, so minus MA, because MA is in counterclockwise direction. VA is passing through point A, so it will not produce any movement about point A, and this 10 kilonewton force is producing clockwise movement about point A. So it will be taken as positive. 10 kilonewton is the magnitude of the force, and lever arm is also equal to 10, and that is equal to 0. So if I rearrange this, I get MA is equal to 100 kilonewton. So this is the value of second reaction at point A. VA is 10 kilonewton and MA is 100 kilonewton meter. And both the reactions are positive, which means that the assumed directions for both of them are correct. So this was the first step, reaction calculation. Next step is to divide the beam into portions. Now let's see how many portions do we need in this case. Let's start from point A and move in the rightward direction towards point B and see at what point we see any change. We find any change in loading or boundary condition. So if we start from A and we reach point B. At point B, we have a point load, and there is that is the termination point of the beam. There is nothing present on the right side of So if I enlist the portions, there will be actually only one portion AB. So in this beam, we do not need to consider 2-3 different portions. There is only one portion, and that's equal to the entire length of the beam, portion AB. So we will draw its free body diagram, and then we will write down its the equations for shear force, bending moment, and then we'll draw bending moment and shear force diagrams. So let's consider portion AB. And in this portion, one second, variable, the location of section is denoted by X, and X in this case ranges from 0 to 10 meters. Okay. Now let's draw a free body diagram for portion AB. This is the section. We have one reaction here. Reaction is 10 kilonewton, and other reaction is counterclockwise movement. Magnitude is 100 kilonewton meter. This distance is X, a section, so the internal forces will get exposed. According to our convention, shear force in inward direction and bending moment in counterclockwise direction. So this is the free body diagram for portion AB. On the equations for sigma Fy equal to 0, and our convention is positive. Now, this how many forces are acting in vertical direction starting from this end. 10 kilonewton is acting in upward direction, so positive 10. Then we move right. What else? This V is acting in downward minus V. There is no force along Y direction. This implies V is equal to 10 kilonewton. So again, portion AB, we have got a constant value of shear force, and that is equal to 10 kilonewton. Okay. Now equation for bending moment, sigma mx equal to 0, and clockwise movement will be taken as positive. Okay, how many movements are there? If I start from this side, this 10 kilonewton force is at a distance x from the section, and it will use. What about this 100 kilonewton meter? It is in counterclockwise direction, so it is 100. What else? Then we have M, and that is equal to 0. Again, shear is passing through the section, so it will not produce any movement about the section. Now, if I rearrange this equation, I get M is equal to 10x minus 1. This is the equation of bending moment for portion AB. Now, we will consider point A and point B, and we will put the corresponding values of x in this equation, and we'll get the values of bending moment at these points. So at A, x is equal to how much? X is 0. So M is equal to 10 into 0 minus 100 equal to 100 kilonewton meter. So the value of moment at point A is equal to, sorry, minus 100 kilonewton meter. And value of moment at point B, at B, x is equal to 10 meters. So M is equal to 10 into 10 minus 100. How much is that? 0. So the value of movement at point B is equal to 0. Now, here is an important point to note. Just like hinge support, external hinge support and roller support, the moment at free end will also be equal to 0. unless there is an externally applied point moment. So value of movement at external, value of movement at free end will always be equal to 0 unless there is an applied point movement at this point. And in this case, if we look at the given beam, there is no point movement acting at this point B. So the value of bending moment, we should already know that the value of bending moment at point B should be equal to 0. And we have got this value equal to 0. So this is logical. And at point A, the value is 100 kilonewton meter. It's equal to the value of reaction at support A. So that also is fine. Now let's draw shear force diagram and bending moment diagram. For that, I will draw the beam again. Here is the beam. 10 kilonewton force, reaction, 10 kilonewton. This reaction is 100 kilonewton meter. Now let's draw the guidelines. Okay, this is going to be our 0 line for SFD in kilonewton. Okay, how much is the value of shear? If you look at the equation of shear, we had got V equal to 10 kilonewton. It's constant, it's positive. So kilonewton, constant value. 10 here, 10 here, and the entire shear force diagram is positive. So the entire shear is positive in this case, and its mass is equal to 10 kilonewton. That completes the shear force diagram. Next is bending moment diagram. 0 line. We are plotting BMD, and our units are kilonewton meter. Now, how much is the value of bending moment at point A? At point A, it is minus 100, and at point B equal to 0. So this is 100, and as we did in the last problem, that we just need to mark the negative values on the negative side or on the lower side of 0. We do not need to put any sign with this. We'll put the absolute value. What this negative means, this negative value means, this means that it should be marked below the 0 line. So we have here at minus 100, and at point A, at point B, the value is 0. Now again, the question is that how should we join these 2 points? Should we join with a straight line or a curved line? And if it's curved, what will be the degree of the curve? That we will see the equation of the bending moment for portion AB. Look at this equation. This equation is first degree. The equation, the power of x or the degree of x is 1. So this should be a straight line. So we'll join these 2 portions, these 2 points with a straight line. And the entire moment diagram is negative in this case. Here we are. This is bending moment diagram for this beam. This beam had only one portion, so portion AB or the entire beam are the same. Last step is to draw the elastic curve. Now, for elastic curve, this time the entire beam bending moment diagram is negative, so it means that the entire beam is hogging, and we have a fixed support here. At fixed support, we do not have any rotation. At fixed support, the beam is absolutely fixed. So in the initial portion of the beam, there will be no rotation. And after some distance from the beam, from the support, the beam will start rotating and it will be hogging. If you look at this, the curvature or the curve of this beam, this is hogging down. Okay, so this is elastic curve. of the beam. So we have shear force diagram, bending moment diagram, and elastic curve of the beam. And this completes this problem. So we will stop here. Thank you.